13 May 1943, near Cape Bon, Tunisia. Oberleutnant Karl-Heinz Adler lay face down in the dust with his hands laced behind his neck, the thunder of British trucks rolling past him, the smell of burned oil and cordite still hanging in the air. A few hours earlier, he had been an officer of the Afrika Korps, responsible for a small motor pool that kept battered trucks and half-tracks running on improvised repairs. Now he was one of tens of thousands herded into an improvised barbed wire cage under a white, punishing sky. He could feel the sun cooking the back of his neck through the thin fabric of his tunic. He heard English shouted, then American voices, then the clatter of mess tins, the murmur of men trying to understand what had just ended. He watched a British soldier idly kick the side of an abandoned German truck and walk away. Adler's mind clung to machinery, to numbers, to ratios, anything but defeat. His training at the Technische Hochschule in Munich, his pre-war work as a junior engineer in a diesel engine division, his patient tinkering with combustion diagrams in a small notebook now hidden inside his tunic. All of it seemed pointless under the leveling fact that General Jürgen von Arnim had surrendered the remaining Axis forces in Tunisia that very morning, ending the North African campaign. Around him, German and Italian soldiers sat in rows, stunned. Some still talked of holding a line in Europe, some of miracle weapons. Adler said little. He simply noted, with the same habit that had once measured piston tolerances, the scale of his own capture, the streams of prisoners, the orderly registration tables, the endless lines of Allied trucks and tanks that had materialized faster than his own side could destroy them. The wider facts, which Adler did not yet know in full, framed his personal defeat inside a much larger calculation. In Tunisia, between late April and 13 May 1943, approximately 250,000 to 275,000 German and Italian soldiers laid down their arms, a surrender on a scale comparable to Stalingrad, stripping Hitler of experienced formations and draining the prestige of the Afrika Korps. Allied units, supported by an industrial base that could replace lost tanks, guns, and aircraft in weeks, had ground down an enemy that was already short of fuel, spare parts, and shipping. The capture sites quickly became vast human reservoirs, fenced and guarded, where men like Adler were tagged with numbers, searched, and processed. Across the Atlantic, planners in Washington and London had anticipated this flood. They were already arranging to move tens of thousands of Axis prisoners from the Mediterranean to the United States, to relieve overcrowded North African cages and to put captured manpower to work in agriculture and industry. By May 1943, American shipyards had launched more than 1,000 Liberty ships, standardized cargo vessels built from prefabricated sections. In total, 2,710 would be completed by war's end, with record construction times measured in days rather than months. These ships, which had carried trucks, fuel, and food to North Africa, would now carry men in the opposite direction. The arithmetic was simple and brutal. Allied shipping capacity was so large that deadheading empty hulls back across the Atlantic was wasteful. Filling them with prisoners turned a logistical problem into an asset. Adler, who had spent months coaxing worn-out engines to life with wire and hope, had already glimpsed this imbalance in the columns of fresh Allied vehicles that never seemed to run out. He sensed, before he fully understood, that his own story would now be written inside that industrial gap. In the holding camp near Tunis, Adler experienced the new system at close range. He stood in line as American officers, assisted by interpreters, took down names, units, professions. When he answered, Maschinenbauingenieur, mechanical engineer. One sergeant looked up and wrote it carefully. His equipment was tagged, his paybook taken, his photograph snapped. He listened, surprised, as a German-speaking American captain calmly explained their rights under the Geneva Convention. Adequate food, medical care, correspondence, no forced labor directly for the enemy's war industry. The words sounded theoretical, like a lecture in military law, until the first hot meal arrived. White bread, meat, coffee that smelled real. Men who had been on reduced rations for months stared at their plates, suspicious, then devoured everything. Adler remembered his own unit in the last weeks, siphoning fuel from wrecks, cooking thin soup behind dunes. Here, in an improvised cage guarded by conscripted Americans younger than many of the German NCOs, the food alone felt like a statement. On the distant docks, he could see the silhouettes of Liberty ships at anchor, cranes moving steadily, cargo nets swinging. Later, years later, he would learn the numbers. Those same generalized cargo shapes were part of a program that could launch dozens of such vessels in a single month. Some assembled in less than 40 days, their 250,000 parts manufactured in plants scattered across the continent. At that moment, standing in the dust, Adler did not know figures. He only saw ships too numerous to count, and trucks that did not break down. When he closed his eyes that night, lying shoulder to shoulder with other prisoners on bare ground, he felt again the pitched rattle of failing German engines in the desert, and involuntarily began redesigning one of them in his head, chasing an old idea about combustion timing and airflow that his pre-war supervisor had dismissed as impractical. Weeks later, when his turn came, Adler was marched under guard to the quay and up the gangway of a Liberty ship bound for the United States, crammed with nearly 2,000 prisoners. In the dim hold, he listened to the ship's engines turning below, the steady industrial heartbeat of a country he had been taught to despise as soft and chaotic. Each day on deck, through salt wind and Atlantic haze, he saw more proof that this image had been false. Convoys stretched to the horizon, rows of cargo ships and escorts, steel and steam in formations so dense it was hard for him to imagine that any U-boat force could truly starve them. In this moving forest of masts and funnels he felt, as many prisoners later wrote in their letters and diaries, a reluctant respect and a growing certainty that in a war of factories and fuel his side had picked the wrong opponent. Official records would later show that by the end of the war, more than 370,000 German prisoners would be held in over 500 camps across 45 American states, part of a total Axis POW population in U.S. custody of roughly 425,000 men. Adler was now one of those numbers, carried west on a standardized hull, driven by mass-produced machinery, a human unit inside an industrial system he only half understood. Yet even here, in the enforced idleness of the crossing, his mind returned to engines. Curious American guards, having noted his profession on intake cards, sometimes asked what he had worked on. He sketched diagrams on scrap paper, showing them how German truck engines squeezed power from low-octane fuel, how wear and heat slowly killed pistons, how a revised airflow could cut consumption. One evening, an older Navy machinist's mate watched him draw an outline of what Adler called an unmöglicher motor, an impossible engine, one that promised higher efficiency at lower weight by rethinking the way cylinders were paired and scavenged. The American laughed and shook his head. "Interesting, Lieutenant," he said, "but engines don't run on dreams." Adler folded the paper away. In his mind, The design did run. He had tested it 100 times on the page. He did not know that this private insistence, born in defeat on a crowded Liberty ship, would one day startle the very people now guarding him. For the moment, he was simply a prisoner moving toward an unknown camp in a country whose power he had only begun to measure. August 1943. Norfolk Naval Base, Virginia. The convoy slipped through a morning fog dense enough to hide the full sweep of the docks until Adler was already staring at it from the rail. When the mist cleared, he saw a panorama that stunned him more than any battlefield. Miles of cranes, piers, and warehouses stretched away until they dissolved into the haze again. The Liberty ship eased into position beside a quay so crowded with other vessels that their masts overlapped like a forest. He could see American workers moving everywhere: stevedores, sailors, men in civilian clothes driving forklifts, women in coveralls handling crates. The noise of engines, cranes, and trucks fused into a steady mechanical roar. To Adler, trained in the measured rhythm of German industry, the scale bordered on the impossible. In Germany, even major ports like Hamburg and Kiel were half dark and half destroyed. Here, every dock blazed with electric light, every crane moved, every rail spur carried freight. Later, when guards herded the prisoners down the gangway and formed them into columns on the dockside, he noticed something that unsettled him more than the lights or the machines. The men directing the traffic, officers, engineers, mechanics, spoke quickly, decisively, yet without the rigid hierarchy he had known all his life. Orders were short, exchanges informal. No salutes, no barking, no shouted slogans. Efficiency without discipline, Adler thought. How can that work? He did not yet understand that he was witnessing the expression of an industrial culture built on confidence and abundance rather than fear. From Norfolk, the trains began to roll west, loaded with prisoners in Pullman coaches marked with chalked serials. Adler sat by the window, watching the American landscape unfold like a series of impossible photographs. Town after town glowed with electric light even at midnight. The lamps of gasoline stations shone at every crossroads. In factories along the tracks, he could see night shifts at work, furnaces blazing, conveyor belts moving. His compartment smelled faintly of oil and upholstery rather than sweat or coal. Once, when the air conditioning faltered, a sergeant apologized through the open door. The word itself, air conditioning, sounded absurdly luxurious. Adler tried to fit it into the vocabulary of war and failed. Around him, officers spoke in low voices about what they were seeing. One had studied economics in Heidelberg and muttered that such electricity must cost millions. Another simply whispered, "They have no limits." As the train crossed the Mississippi at St. Louis, Adler saw below him barges packed with grain sliding along the river, more food than entire German provinces could have harvested. Somewhere near Kansas City, the guard handed out sandwiches: white bread, meat, cheese, a slice of tomato. Adler took a bite and realized he could taste fresh milk in the butter. It was not propaganda. It was routine. That night he could not sleep. He kept picturing the assembly lines he had glimpsed through factory windows, the fields lit by headlights where machines worked even after dark. His engineer's mind began breaking down what he saw into numbers: horsepower, output, kilowatt hours. Every figure he guessed exceeded the limits of German capacity. The statistics bore him out. By the summer of 1943, American industry had reached a level of mobilization unprecedented in human history. Factories produced 45,000 tanks, 100,000 aircraft, and more than 8 million tons of shipping in that year alone. The Ford plant at Willow Run was turning out one B-24 Liberator bomber every 63 minutes, while Kaiser's shipyards in California built Liberty ships in as little as 4 days. Electricity output, a key measure of industrial strength, surpassed 500 billion kilowatt-hours, 5 times Germany's total. Behind these numbers stood an entire social machine that seemed to Adler as alien as the landscape outside his train window. Women made up more than a third of the industrial labor force. African American workers, long excluded from skilled trades, now manned cranes and welding torches. Teenagers, retirees, immigrants, every hand that could hold a tool contributed. For the German prisoners watching from the train, this diversity contradicted everything they had been told about a decadent, divided America. The factories ran day and night, the farms overflowed, and the people appeared well-fed, confident, and united. The war had not impoverished them, it had accelerated them. When Adler finally reached Camp Hearn, Texas, after 3 days and nights of travel, he stepped down into a dry heat that shimmered above the rails. Rows of wooden barracks stretched toward a distant water tower, painted with a white star. American guards stood casually at the gates, rifles slung but not raised. Inside, order reigned without menace. Barracks had electric light bulbs, running water, and flush toilets. The mess hall smelled of bread and boiled meat. On the notice board hung a printed schedule in both English and German listing work details, mealtimes, and classes. Adler read it twice, disbelieving the detail that prisoners could attend English lessons or request books on technical subjects. The following week, he was assigned to the camp's motor maintenance section, where a handful of German mechanics helped repair farm trucks for nearby fields. The first time he entered the workshop, he stopped in silence. Tools were arranged in neat racks. Replacement parts were stacked in labeled bins. The foreman, a civilian named Howard Johnson, greeted him with a handshake and said, "You're the engineer, right? Let's see what you can do." That evening, Adler wrote in his diary, "They treat us not as enemies, but as technicians. Their tools are new, their machines simple and strong. If Germany had such factories, we would not have lost Africa." He closed the notebook and stared at the bare bulb above his bunk until the light blurred. He had seen the heart of his art, of his enemy's power, and it ran not on ideology, but on precision and plenty. By late autumn 1943, Camp Hearn had become a small, functioning city of prisoners. The rows of barracks stretched across nearly 300 acres, housing over 4,000 Germans and a smaller number of Italians under the steady Texas sun. The Americans called it the Fritz Ritz, half mockingly, though the facilities owed nothing to luxury and everything to efficiency. For Adler, the camp's motor workshop became a lifeline. He worked from dawn to afternoon alongside other mechanics, repairing generators, farm trucks, and small engines used around the compound. Most of the tools were American-made: snap-on wrenches, Black & Decker drills, precision instruments with tolerances that astonished him. The American supervisor, Howard Johnson, often encouraged them to test new setups, even to suggest improvements. Adler was startled by the informality. There was no threat of punishment for error, no hierarchy separating officers from workers. When one of the German corporals proposed a faster way to change spark plugs using an improvised socket attachment, Johnson praised the ingenuity and ordered a set of them made for the camp's vehicles. It was the first time in years Adler had seen mechanical creativity rewarded rather than buried under regulations. In the evenings when the desert air cooled, He would sit by the barracks window drawing diagrams in the margins of scrap ledgers. The impossible engine, the design that had haunted him since the Atlantic crossing, began to take shape again in pencil lines, paired cylinders sharing a variable compression chamber, scavenging exhaust through a two-step airflow valve, eliminating the heavy supercharger every other design required. Outside the barbed wire, the United States was entering what historians would later call the peak of the arsenal of democracy. In 1943, more than 19 million Americans worked in war production. U.S. shipyards turned out nearly 65 million tons of new vessels that year, and airplane plants produced 8,400 aircraft each month. The war economy functioned with a mathematical precision no enemy could match. 85,000 tanks, 300,000 aircraft, 700,000 trucks by the end of 1944. Adler began hearing these numbers in passing, snippets from guards, headlines in camp newspapers translated from English, even from American radio programs played during mealtimes. The statistics were staggering to a man whose entire division in North Africa had counted 120,000 vehicles, half of them constantly broken. What impressed him most was not only the quantity, but the system that produced it. At Camp Hearn's library, where prisoners could borrow English books, Adler found a technical manual on internal combustion engines used by the U.S. Army. He studied its diagrams carefully and realized how American engineering prioritized standardization. The engines were simple, modular, designed for mass assembly and field repair. They did not chase theoretical perfection. They aimed for consistency and speed. It was an engineering philosophy opposite to the German obsession with fine tolerances and custom design. That evening, he wrote in his notebook, "They build machines as they build their nation, identical parts fitted with confidence, powered by abundance." Life inside the camp moved with a rhythm that softened captivity into routine. Prisoners woke at 6:00 a.m. to bugle calls, stood for roll, ate breakfast of oatmeal, bread, and coffee, then walked in groups to work assignments. Some were sent to local cotton farms or sawmills, earning small wages in coupons redeemable at the camp store. Others worked in the kitchens or hospital. Adler's team remained in the motor shop, where they began repairing surplus engines for agricultural use. Over time, he earned a reputation among both prisoners and Americans for precision work. Johnson trusted him to oversee tasks without supervision, and even allowed him to modify a captured German Opel engine for demonstration. One afternoon in November, while testing the Opel's carburetor, Adler spoke hesitantly to Johnson about his own design. He expected dismissal. Instead, Johnson leaned over the diagram and said, "If you can make it work on paper, Lieutenant, I'll find you some scrap metal." The next day, Johnson delivered a crate of old pistons, cylinder heads, and a worn-down lathe. Within weeks, Adler and two fellow mechanics built a rough model of the engine, a small single-pair prototype that could be turned by hand. It ran for 20 seconds before seizing, but those 20 seconds filled Adler with something he had not felt since before the war: belief in his craft. Guards gathered around the bench, listening to the brief hum. One of them, a mechanic from Kansas City, whistled low and said, "You're on to something, Kraut." Beyond the camp fence, the same forces that had captured Adler were shaping the world on a scale few inside could fully imagine. American gross national product had doubled since 1940, and war production accounted for nearly half of it. Every minute, factories produced 650 artillery shells. Every hour, 30 trucks. Every day, enough steel to lay 500 miles of railway. The U.S. Army Corps of Engineers was building bases across the Pacific while new aircraft carriers slid into the Atlantic from Newport News and Brooklyn. For the prisoners, these facts filtered in through official bulletins and Red Cross newsletters. But for Adler, numbers now carried personal meaning. His impossible engine, which combined the German instinct for efficiency with the American pragmatism of simplicity, became a symbol of reconciliation between the two industrial cultures. In January 1944, Johnson arranged for the camp commandant to see the model. The major watched the crude mechanism turn and asked in clipped English what made it special. Adler explained, struggling for words, that it could generate equal torque with fewer moving parts, reducing weight and fuel consumption by a third. The major nodded slowly. "If you ever get the chance, write it up properly," he said. "The engineers in Detroit would like that." That night, Adler added a single line to his diary. "They listen." For a prisoner of war, that was miracle enough. Spring 1944 brought the first true thaw of the Texas winter, and for Adler, the slow transformation of captivity into purpose. His prototype engine, repaired and refined through weeks of work with salvaged parts, now turned smoothly by crank. The two-cylinder test rig sat bolted to a wooden frame inside the camp workshop, its pistons operating in paired motion, exchanging pressure through a shared chamber that allowed higher compression without detonation. When it ran for the first sustained minute in March, its noise was uneven but unmistakable, a rhythmic pulse that drew a small crowd of prisoners and guards alike. Johnson, the foreman, stood with a stopwatch, grinning. 70 seconds, Lieutenant," he said. "That's something." Adler, who had scarcely smiled in months, allowed himself a nod. For him, it was not victory, but verification. The theory he had nurtured since his pre-war days in Munich was no longer a drawing in a notebook. It was a living engine. Word of the contraption reached the camp commandant, then an engineering professor visiting from Texas A&M, who occasionally lectured prisoners in the re-education program. The professor examined the crude machine and recognized the principle at once, a compound compression layout that prefigured what would later be called turbocharging. He asked Adler for notes, diagrams, anything written. Within days, Johnson typed them up and sent copies to a contact at the U.S. Army's Engineering Division in Fort Sam Houston. Across America, that same spring, the scale of industrial mobilization reached its peak. The U.S. War Production Board recorded 96,000 aircraft, 28,000 tanks, and over 60 million artillery shells produced in 1944. Electricity generation surpassed 600 billion kilowatt-hours. Shipyards launched the 2,710th Liberty ship, the last of its class, while new Victory ships, faster and larger, replaced them. In the Midwest, automotive plants now converted to peacetime experimentation, testing fuel efficiency and alternate materials for the post-war market. Within this flood of innovation, Adler's small prototype was an invisible drop, yet the circumstances that made its creation possible were unique. American policy under the Geneva Convention allowed prisoners to engage in educational and non-military technical work. By early 1944, over 40,000 German POWs were enrolled in vocational programs across the United States, many in agriculture and mechanics. Camp Hearn's workshop thus became one node in a vast experiment in rehabilitation through labor and learning. Adler's project, while unauthorized, fit perfectly into that rhythm. It represented what the Americans prized most: practical results from theoretical minds. When Johnson received a letter of inquiry from Fort Sam Houston, asking for detailed specifications. Adler felt both excitement and guilt. He reminded himself that sharing such work might be considered collaboration. Yet he also knew the war in Europe was entering its final stage, and his loyalty had shifted inward, from a regime to the craft of engineering itself. In June 1944, when news of the Normandy landings reached the camp, the reaction among prisoners was mixed. Some cheered for Germany's resistance. Others, like Adler, said little. He had already guessed that industrial output on that scale, 6,000 ships, 11,000 aircraft, 150,000 men in the first wave, meant the end was mathematically certain. He spent the evening after hearing the broadcast adjusting valve, timing on the prototype. The next morning, an American officer from the Corps of Engineers arrived unannounced. He introduced himself as Captain James Reynolds and carried with him a briefcase containing technical notes typed from Adler's earlier diagrams. Reynolds asked to see the device. For 2 hours, he and Adler spoke across the workbench using a blend of English and German, the conversation drifting from compression ratios to fuel types. Reynolds was polite, professional, occasionally amused by the irony of learning from a captive. "Your design cuts waste," he said finally, running his fingers along the bolted frame. "Not by magic, but by logic. We could use men who think like that." Before leaving, he handed Adler a copy of the Geneva Convention Clause on Prisoner Inventions, which allowed POWs to retain intellectual rights through neutral registration. It was an extraordinary gesture, an acknowledgement that a prisoner's mind remained his own property. That night, Adler lay awake listening to the Texas wind scrape against the barracks walls, realizing that his impossible engine was no longer just a private fixation. It had entered the record. By the end of that summer, letters from Fort Sam Houston confirmed that the U.S. Army's technical board had replicated Adler's design using standard parts. Their prototype, tested under controlled conditions, achieved an 18% improvement in fuel efficiency compared to equivalent displacement engines. The report praised its elegant airflow economy and notable reduction in component stress. It concluded that while not immediately practical for mass production, the concept merited further study. The findings circulated quietly among Army engineers and were later passed to the Society of Automotive Engineers for review. None of this was known to the general public, nor did Adler's name appear on the documents. Within Camp Hearn, life continued as before: roll calls, farm work, football matches, English lessons. But beneath the routine, a subtle shift occurred. American guards now treated Adler with visible respect, calling him professor rather than lieutenant. Johnson arranged extra workshop hours and a small allowance of materials. For Adler, the workbench became a refuge from the noise of war, a space where creation replaced destruction. He could not yet imagine that the principles proven in that dusty Texas shed would, within a decade, influence designs in post-war Germany's reborn automotive industry. For now, all he knew was the hum of his engine and the quiet, unmistakable satisfaction of having turned captivity into invention. Autumn 1944 brought a different light to Camp Hearn. The sun still burned the Texas plains, but the war's distant rhythm had changed. German morale collapsed alongside the front lines, and radio bulletins from Europe now spoke of Allied advances through France and the encirclement of Aachen. For Adler, the news felt both distant and inevitable. His life had shrunk to a schedule of mechanical precision: morning roll call, workshop duty, evening lectures. The prototype still sat in its place of honor in the camp's motor shed, occasionally started for visiting officers or technical delegations. Each time it sputtered to life, It reminded Adler of the fine line between captivity and purpose. He no longer dreamed of returning to the Reich's factories. Instead, he imagined a different Germany, one where engineers might serve industry rather than ideology. Among his fellow prisoners, this talk was dangerous. Many still clung to loyalty, muttering about wonder weapons and secret rockets. Yet Adler saw through it. He knew that even those supposed marvels, the V-1s and V-2s, were built on the same premise that had doomed them: complexity without capacity. America's advantage, he realized, was not just technology, but its simplicity multiplied by millions. In October, an American journalist visited Camp Hearn on assignment to report on POW re-education programs. She was escorted through the barracks and work areas, notebook in hand, her shoes sinking into the dusty soil. When she reached the motor shop, Johnson introduced Adler simply as the German engineer with the impossible engine. The journalist watched silently as Adler demonstrated the device, cranking the handle while Johnson explained its principle. Later she asked, "Why keep building when your war is over?" Adler hesitated, then replied through the translator, "Because engines have no politics. They work or they don't." The line appeared in her article weeks later, printed in the St. Louis Post-Dispatch under the headline, "Captured Germans Learn the American Way." It caused a small stir at Fort Sam Houston, where the engineering board kept copies. Captain Reynolds wrote to the camp, "Tell your lieutenant that his statement impressed people in Washington." Adler never saw the newspaper, but guards mentioned it, some teasingly, others with respect. The attention brought new visitors, professors, Army engineers, even a few representatives from General Motors studying efficiency reports. Each took notes, some asked for blueprints. Adler signed nothing, but his drawings continued to circulate. Outside the wire, the same year saw the American war machine reach an intensity no nation had ever achieved. U.S. industry produced 47 billion rounds of ammunition, 700,000 military vehicles, and 42 billion gallons of fuel. The domestic economy ran at full employment, women now filling half of all factory positions. In the Midwest, where automobile giants had transformed into weapons manufacturers, production records were shattered daily. The Detroit Arsenal alone built 25,000 tanks by the year's end. Yet amid this mechanical triumph, small ideas like Adler's were quietly shaping the post-war world. American engineers, anticipating peacetime, began studying every scrap of foreign technology: German optics, Japanese metallurgy, British radar, and among these reports were summaries of prisoner experiments. Most were minor curiosities. A few, including Adler's, hinted at future applications for civilian engines, aircraft compressors, and fuel systems. His layouts reduced component stress and high compression ratios would later echo in automotive designs of the 1950s, though his name would remain absent from the patents. As 1944 closed, the camp's atmosphere changed. Re-education officers distributed pamphlets about democracy, Reconstruction, and the future of Europe. English classes grew crowded. Prisoners signed up for correspondence courses in agriculture, physics, and mechanical drafting. Adler, now fluent enough to converse freely, helped translate engineering manuals. He wrote polite letters to his parents in Munich through the Red Cross, uncertain if they reached anyone alive. When he was invited to give short lectures on engine maintenance to other prisoners, he accepted. Standing before rows of weary men, he began each talk not with propaganda, but with mathematics, ratios, pressure, efficiency. He ended with the same quiet refrain: "Engines cannot lie." It became a sort of motto within the workshop. Johnson had it painted on a scrap of metal above Adler's bench. One evening, as the sun dipped behind the barracks, Johnson handed Adler a small parcel wrapped in cloth. Inside lay a new micrometer engraved with the initials HJ and the date. "You'll need it someday," Johnson said. Adler held it for a long time, unsure whether he would ever again see a German factory. By early 1945, word of his engine's test results had reached as far as Washington, though bureaucracy ensured he never knew it. The U.S. Army's technical evaluation concluded that the design demonstrated promising efficiency gains for low-octane fuel engines, warranting further civilian research. The phrase meant little to policymakers focused on ending the war, but to engineers it carried quiet weight. At Camp Hearn, the guards began dismantling parts of the facility in anticipation of eventual repatriation. Fewer patrols, fewer roll calls, less hostility. Adler sensed the approaching end, not through speeches or orders, but through silence. The sudden absence of fear that marked a world shifting from war to peace. Yet in the stillness of those last months, he returned to his notebook and drew the engine again from memory, refining it line by line, until its form was almost elegant. When he finished, he closed the cover and wrote on the first page, "Freedom is precision." March 1945. The radio in Camp Hearn crackled with static as prisoners gathered around the loudspeaker mounted in the mess hall. The announcer's voice, translated by an interpreter, carried news that silenced the room. Cologne had fallen. The Allies had crossed the Rhine, and American troops were now on German soil. Adler stood near the back, arms folded, eyes fixed on the wooden floor. He felt no shock, only confirmation of what he had already known from the hum of the camp's telegraph and the tired tone of the guards. Germany was finished. Yet as the news spread, anger rippled through the prisoners, shouted curses, clenched fists, arguments about betrayal. One younger sergeant slammed his tin cup against the wall, shouting that the fatherland would rise again. Adler said nothing. He returned to the workshop and stared at the silent engine on his bench. For months, it had been a symbol of what he believed Germany could have become. Efficient, modern, rational. Now it stood as a monument to what had been lost. Johnson entered quietly behind him and switched on the single bare bulb overhead. "It's over, Karl," he said softly. Adler nodded once. He did not mourn the Reich. He mourned the waste, the talent, the industry, the years consumed by ideology instead of innovation. The Americans, too, sensed the transition. Orders arrived from Washington, instructing camp commandants to begin preparing skilled prisoners for repatriation and reconstruction. The War Department's intellectual reorientation program had shifted from neutral education to post-war planning. Selected engineers, doctors, and teachers among the prisoners were now grouped for advanced study. Adler's name appeared on one of those lists. He was transferred to a smaller compound near Fort Sam Houston, where 40 German technicians worked under supervision to catalog their wartime specialties. The Americans called it a technical rehabilitation group. For Adler, it felt like a laboratory reborn. He was issued drafting tools, a proper workbench, and access to an American library stocked with engineering journals. There he saw for the first time the detailed results of his own engine's test report, typed neatly, with efficiency graphs and fuel curves plotted against comparable U.S. models. The report credited him only as Foreign Technician, Camp Hearn. Still, it was proof. He studied the chart for hours, noting how the American engineers had modified his design with lighter alloys and standardized fittings. In the margin, one reviewer had written, "Promising efficiency gains worth exploring for peacetime vehicles." It was the first time Adler had seen his work treated not as enemy intelligence but as useful research. Meanwhile, Europe disintegrated. Dresden burned in February, Berlin lay under siege by April, and the Third Reich collapsed into surrender on May 8, 1945. In Texas, the news came through a short announcement on Armed Forces radio. Some prisoners wept, others sang quietly. Adler walked alone to the edge of the wire that evening and looked out across the open plains, glowing under the sunset. He thought of Munich, his parents, the river Isar, the factory floor where his career had begun before war swallowed it. The world he had known was gone, but perhaps something could be rebuilt if Germany could learn what he had seen here. That summer, the American officers overseeing the re-education program began distributing pamphlets about the Marshall Plan's early drafts and the principles of democratic industry. They encouraged men like Adler to imagine a future beyond the army. "You will rebuild your country," Captain Reynolds told him one day, "just not the one you left." When Adler asked what he meant, Reynolds replied, "You've seen how we build things. Now build that way." By late 1945, Camp Hearn's population had thinned as ships carried prisoners back across the Atlantic. Repatriation was carefully organized. Medical checks, fingerprinting, inventories, farewells. On the day of departure, Johnson accompanied Adler to the transport bus. He handed him a small bundle wrapped in cloth, the micrometer and a few of Adler's blueprints, neatly folded. "They said we have to keep the rest for the archives," Johnson said, smiling. "But this much is yours." Adler clasped his hand firmly. "Thank you," he replied in halting English, "for treating me as an engineer, not a prisoner." Johnson nodded. "That's because you were one." The bus drove away under the same bright Texas sun that had greeted Adler 2 years earlier. From the window he saw the workshop recede into dust, the wooden barracks shrinking into the horizon. In his pocket lay the micrometer, cool and solid, the one instrument he had truly earned in captivity. As the convoy passed through the gates, Adler realized that his impossible engine, born in defeat, had become his passport to a new world. The Atlantic crossing in November 1945 was calm. The Liberty ship, now repainted and reclassified as a transport, carried 1,800 returning prisoners. Many were silent, their eyes fixed on the endless gray water. Adler spent hours on deck watching the waves break against the hull, the steady rhythm of the engines below reminding him of his own design. Somewhere inside the cargo holds, machines like these, his captors' creations, had carried not just weapons but ideas. In a way, the American engine had remade him. When the ship reached Bremerhaven, the ruins of the port were visible from miles away. Twisted cranes, gutted warehouses, rubble where cities had stood. Yet amid the destruction, Allied dock workers labored under floodlights powered by portable generators, unloading food and building supplies. Electricity again. Order again. As Adler stepped onto German soil for the first time in 3 years, he felt both foreign and familiar. The efficiency, the discipline, the light, echoes of what he had seen in America, had returned here, transplanted like seeds. He thought of Johnson's words and understood them fully now. The true lesson of his captivity was not humiliation, but the realization that power came from creation, not domination. The train that carried Adler inland from Bremerhaven sure wound through a landscape of ruin. Town after town lay flattened, churches roofless, factories gutted, rail sidings twisted like ribbon. Yet amid the devastation, reconstruction had already begun. Allied supply convoys rolled through the wreckage, bringing lumber, cement, and food. In Bremen, Adler saw a British lorry depot lit by floodlights, powered by American generators identical to those he had once repaired in Texas. He smiled faintly at the sight. The same machines that had held him captive were now illuminating his homeland. His destination was a displaced persons center near Hanover, where returning prisoners were processed before release. There, officials asked his profession. When he said engineer, one officer looked up and said, "You're the sort we'll need." Within a week, Adler was assigned to assist the British Control Commission in restoring power to regional workshops. The work was menial: wiring, generator testing, fuel audits, but to him it felt like resurrection. In the evenings he copied technical notes from memory, redrawing the plans of his engine on Allied stationery. When an English officer asked what he was designing, Adler replied, "A lesson I learned in America." The following years blurred into rebuilding. 1946 brought hunger and shortages, but also the first stirrings of Germany's economic rebirth. Former industrial engineers from across the shattered nation met under Allied supervision to form technical advisory boards. Adler joined one such group in Hanover, tasked with studying small engine designs for agricultural equipment. The Allies wanted efficiency, not power, machines that could run on low-grade fuel and be repaired by untrained farmers. It was the perfect application for his two-cylinder layout. Using parts scavenged from abandoned vehicles and British surplus, Adler constructed a working prototype in the basement of a ruined brewery. When it started on the third attempt, its rhythmic, balanced sound echoed through the stone walls. British observers recorded the test results and forwarded them to the Ministry of Economic Reconstruction. The report described an engine of remarkable simplicity, high compression tolerance, and minimal maintenance, noting its lineage from a concept first demonstrated by a prisoner in Texas. Adler was never officially credited, but within 2 years, the same principles appeared in licensed designs from newly revived German manufacturers like Deutz and Hanomag. The idea had survived the war, crossing oceans and ideologies to find its purpose. By 1950, West Germany's recovery astonished the world. Industrial output had surpassed pre-war levels. New factories rose from ruins with American aid through the Marshall Plan. The Ruhr's steel production exceeded 12 million tons annually. German engineering, once devoted to conquest, now served civilian progress. Adler, by then head of a small design bureau in Hanover, watched apprentices operate milling machines under fluorescent lights and felt a quiet pride. His engine had evolved into a compact tractor motor exported to France and the Netherlands. When American trade delegates visited in 1952, one of them, a gray-haired man with the easy posture of a Texan, approached him after the demonstration. "Name's Howard Johnson," the man said, extending his hand. "Figured I'd see what became of that crazy German design." Adler stared, momentarily speechless, then laughed. "It runs," he said simply. Johnson grinned. "Told you it would." They walked the factory floor together, talking about tools and tolerances, as if the years between them had vanished. That evening, Johnson left behind a small package on Adler's desk, a new micrometer, engraved with 2 words, "Keep building." In the decades that followed, Adler's engine remained a quiet milestone in mechanical history, rarely cited but widely felt. The principles he proved in captivity, paired cylinder balance, shared compression, simplified fuel efficiency, became standard across post-war Europe. By the time he retired in 1965, West Germany's export economy stood second only to America's. When interviewed by a British journalist late in life, Adler was asked whether he resented that his name never appeared in textbooks. He smiled and said, "Engines don't care who built them." On his workshop wall hung a faded photograph of Camp Hearn, the same dusty yard, the same wooden shed where the first prototype had coughed to life. Beneath it, in his handwriting, were 3 words that had guided him from captivity to creation. Freedom is precision. His story stands as one man's testament to the power of ideas over ideology, proof that even in war's darkest captivity, the human drive to build can outlast the impulse to destroy.